Okay, good morning, folks. This is the last lecture of week 10. Today, I'm going to show you a few tips for adding some code to CATIA, which does some of the motions that are more complicated possible. In order to do that, and there's going to be only one lecture on this. I was debating whether I should have a part of Tuesday's lecture also on this, but you know basic programming, you have basic programming skills. You have done it in MATLAB, you have done it in C, and it's really the same thing. So I'll just show you how the process works and do a simple problem. Then you have an opportunity to practice a very simple problem on homework number 9 that has already been posted, okay, for next week. The problem that we're going to be doing is a track. We have done this problem. So we have a track, and then we have a block, and think about as a disk on top of that block. Imagine that block is a helicopter, and the disk is the disk is the rotor or the blade of the helicopter, the propeller of the helicopter. Think about it like that. Now I put a marker here so that you can see what happens when this thing spins, okay? Because if there's no marker here and it spins, you just don't see anything. You just see an orange big blob sitting there. Okay. Now, you know how to do this problem. For example, if I told you what the speed, of the block is, you know how to write a code for it. The code is very simple. You just write down, position equal to the speed times time, etc., etc. Okay, so actually let's start with that situation. So we know the speed of the rotation of the disk, and we know the speed of the block, and we're going to do this problem. Okay, and then we will make changes later on, which makes it more complicated. For example, later on I'm going to say, oh, during the first 4 seconds, the speed of the block is 2 inches per second, and then in the time interval 4 to 6, the block doesn't move at all, and then from 6 to 10 seconds, the block goes in the opposite direction. That means the speed is negative at the same velocity as how it started. And this is the profile for the disk. Okay, this was for the block, this was for the disk, and of course, when you put it together, both of these are the inputs to the problem. Okay, all right. But first, let's start with a constant velocity. Now, I'm not going to make the parts. The parts have already been created. Therefore, I'll just bring them in. You know how to make a block, right? So let's start with a new file. Okay. Immediately, I'm going to save it. File, save management, save as. Now let's see, we have something called July, yeah, right, no, July 23rd, I have something called July 23rd somewhere. Actually, it's this one, right? Block, track, yeah, I think it's this one. Yeah. Okay, so I'm going to give it a different name, by the way. So it's going to be product with July, with, what are you guys, Lab 52? Lab 52, or 51 actually, Lab 51. Now, since the parts are already created, I'm going to insert them. So it's going to be insert existing components in there. From that same folder, it's these three: part 1, 2, and 3. Block, track, and the propeller. And there we are. Okay. Now, let's go to the assembly design. There's no mechanism created. We're going to do that in a second. So let's move these things apart so that we can see what we're doing. There is your disk. Wait a minute, I don't have the marker up there, so I'm going to fix that in a second. Okay, let's go. Let me go put a marker up there. So this, which one is this? This one is the first one. Double click on it. Okay, so on that top face, I will sketch. I thought I already saved that, but it looks like I didn't. Okay, so let me make a little rectangle like that. Okay, yeah, and then exit and make a tiny pocket or a pad. No, actually, I'll look. Yeah, okay, fine. Okay, there we are. Let's go back. Okay, so we know that this guy will travel along that track, along that edge. So that's it's going to be a prismatic joint. So it's going to be, for example, this face and that face, and this edge and that edge. Update. There we are. This is going to turn into a prismatic joint. By the way, it's a good idea to anchor something. I'm going to anchor the track. Okay, good. And then I'm going to post this thing or mount this thing on that shaft. So coincidence between the axis of this and the axis of that, which is already coincident because I just translated it, and coincidence between, say, the top face of this and the bottom face of that. Update. There we are. Okay, so save this. Incidentally, this whole thing is 20 or 11 inches, I believe. Yeah, block is 1 inch. This is 11 inches, and this one doesn't matter what the size is. Okay, now are we going to go to digital mockup? Get the magic wand out. New mechanism. Auto create. Say okay. You should be able to tell me what joints are going to get created. One of them I already told you is going to be prismatic because I already told you. Now, having done this thing for, I don't know, for the 3 weeks, you should be able to tell me what the other joint is. The other one is a revolute joint, okay, which is between the disc and the block. And if you don't know that, if you did not know that, you're going to be in trouble and you have to catch up. Okay, good. Now, the reason it's a 2 degree of freedom because a revolute joint has 1 degree of freedom, a prismatic joint has 1 degree of freedom, and therefore you have total of 2. Now, obviously, you can make these things angle driven. This prismatic one, we want to make it length driven. Say 0 to, I don't know, I told you this is 10 inches long, so I make it 10. Okay, and this one is a angle driven, 0 to 360. Of course, now you can make a cartoon. In other words, you can move things around, but this is at your discretion right here. This is for the prismatic joint. This is for the revolute joint. You can see that it's turning up there. Okay, but now we want to put some physics into this. And the first step is nothing complicated like that. These are things that you have done, you should be able to do. So let's say the speed of the block is, I don't know, maybe 2 inches per second. Okay, so we know how to do that. You click on f of x. You click on the mechanism. This is the position of the block. The formula equal to 2 inch per 1 second. Okay, that's wrong. 2 inch divided by 1s. Oh, my keyboard. It's changed. I'm going to change my keyboard. Oh, let's see. Divided, yeah, 1s times time. The time is right here. Double click. Okay, good. And the speed of the propeller, let's say it's 60 RPM. That's my favorite number because 60 RPM is 360 degrees per second. Okay, so add a formula, 360 degrees, EEG divided by 1S times time. Time. Scroll down, find time, double click, and OK. Excellent. Say OK. Now you're going to do simulation with laws. Over a 10-second period, that means this is going to get there. Let's see now, 10-second period means, I'll do it 5 seconds because remember the speed of the block, I said it's 2. So if this whole thing is 10, I'll do it over 5 seconds. Otherwise, the block is going to leave that track, which is okay. There's nothing wrong with it. It's just I don't want to. Okay, and play it. So this is going to reach the end, and this propeller is going to turn 10 times. No, actually 5 times. 5 times. Good. Rewind. Okay. Now, what we want to do is, however, do something like this. In other words, during a 10-second interval, okay, during a 10-second interval, the first 4 seconds, the block is going to have a velocity of 2 inches per second. And then between seconds 4 and 6, the block is going to sit there idle, whatever it is. And then between time 6 and 10 seconds, the block is going to go with a velocity of minus 2 inches per second, which means it's going to go backward, basically. Okay? And the propeller is going to have something like that. So start rotating between 0 and 4. It start rotating at, this is 30 RPM, 180 degrees per second. Then during that same time, the propeller still stays idle at that location, wherever it was. And then the last 4 seconds, the propeller turns in the opposite direction. For example, if this is counterclockwise, this is going to be clockwise at the speed of 90 per second. I want to know how this information is inputted into CATIA. Okay? All right, let's go here. And I'm going to caution you that because I already have laws here that I just did a couple of minutes ago, when I try to impose that program that I'm going to write, it's going to come back and say, hey, do you know that you already have some stuff here? Would you like me to deactivate it? Or is this a slip that you made? You didn't know that. So I have 2 choices. I can delete these so that it won't ask me that question, or I can leave it here and it's going to ask me that question. Okay, so let me delete it. I cannot, yeah, delete it. Let me delete it. Delete. Okay. Before I do that, are there any questions? Because remember, this programming thing is going to be 1 session only. You know how to write programs. Simple program. I'm not expecting you to write 50 lines of code. But these are things that if you feel weak, you have to practice on your own. Okay? Of course, there's a homework problem. All right, so here's what we're going to do. We are going to a different workbench. I've never been there. Start, scroll down, knowledgeware, knowledge advisor, knowledgeware, knowledge advisor. You click on it, and as soon as you do that, of course, everything changes. You don't recognize any of these, but I want to show you here this particular one that I pulled out. It says reactive features. I have no clue why they call this thing reactive features. I don't know. But in the second icon, it's kind of hard to miss. It says if X, comma, Y embraces. Okay, this. It looks like it's talking about programming. You click on it, and it says, okay, you want to write a code? or you want to set up a rule, basically, yes. This is just a name, rule 1. I'm going to call it my rule, my rule, my rule, my rule. Okay. There's good date here, etc. So we say fine. What happens when you say okay? This thing opens up, rule editor, and notice that there's stuff here. For example, keyword. See that if you click on the keyword, this parameter is everything that you can find in CATIA for this model. Everything, dimension, stuff like that. Keyword is if, else, if, and there's a whole whack of other stuff that right now I'm not interested. All I want is to write a code, a simple code. So I'm going to say if. Now, in case you forget how to write if, you can click on the keyword, double click on this, and it's going to put you there. Put it there. It's so simple that I don't have to do that. Let me put it back. Oh, before I do this, I don't need all this junk. All I want is the stuff related to mechanism. This is it. I want the time, I want the command for the angle, and I want the command for the length. I don't care about those other stuff that goes here. So if time less than, now you have to go back and forth between this plot and that plot, less than 4, speed is 2, right? Yeah. So less than 4, do not forget to say 4s, because if you don't put that s there, it's going to come back and say, hey, your units are screwed up, because you're talking about time, which is a unit of second, less than 4. What is 4? 4 miles? 4 apples? So that s is important. If you miss that s and you don't know why this happened, you're not going to be able to do the problem. That problem is basically down to 2. Okay, that's what I'm saying. You have to practice. Okay. Now, I have 2 things to do. I can do this thing separately for the propeller. I can do this separately for the propeller or the block and the disc. But in this case, I can do it simultaneously because these times are all the same. If these times, for example, if the propeller motion during time interval is different from this, then I suggest you write two rules, one for the block, one for the propeller. In this case, because these breakpoints are all the same, although in the same instruction. Now, so you put braces here, and all the instructions that are to be executed are going to be within the braces, and there are two of them. Okay, there's 2 of them. If there was only one, there wouldn't be a problem. We just don't need the braces. But if there's 2, then because you want both of them to be executed, you put braces, open it, and then close it. So let's see now. So the length right there, it put the braces here. Okay, I don't know why it shifted to the left. Length is equal to 2 inches over 1 second times time. The usual stuff that we did before. And on the next line, angle equal to, now let's look at this again. Angle is, this was 180 degrees per second, okay? 180 DEG divided by 1S times, and close the braces. Hit return. Else, if time less than 6, okay, less than 6 seconds, right? You can also say 6 and less than 6 and bigger than 4, but it's not necessary. 6 and 6 seconds, do the following. Braces, the position equal to, look, it stays at this 8 inches. During the 4 second to 6 second, the block stays at 8-inch location. So you have to say it's equal to 8. 8, do not forget to put IN. And angle equal to that thing stays at, I believe it was 720, correct? It was, yeah, 720 degrees. 720 DEG. Close the braces. If you left the DEG, or if you left the S here, when you try to close this thing, it's going to come back and give you an error message saying that, you know, units are not consistent. Go fix it. Basically, it's going to give you a syntax error, right? And finally, else means anything else. else braces. Where's that? Braces. Now, the length is equal to, remember, it is sitting at 8 inches, but it goes in the other direction now, minus 2 inch per 1 second times, oh, looking for times here. All right, right here, times time. It is quite possible that you make errors here, you make syntax error and things like that. But anyway, you start like this. So notice that it says the position is equal to 8 inches that it was before, minus, because it's going in the opposite direction, 2 inches per second times time. And for angle equal to, remember it was sitting at 720 degrees per second? 720 DEG minus, now because it propeller will now turn in the opposite direction, and it's at 90. It was 90, I believe, 90 degrees per second. So instead of 180 that it was going like that, it's going to be minus 90. So minus 90. Did I do that? No. Minus 90 DEG divided by 1s times time. And close the braces. Where is this? Okay. And pray that there is no mistake. Okay, because otherwise you have to go fix it. Okay? In all likelihood, there will be mistakes somewhere. Okay. Now, when you look at the video solution, for homework number 9 that is posted, I did not delete those commands. This is why later on you have to, you know, associate that. But here we're going to see how it's going to work. You see now it's right there. Now, in the video solution that is posted, it says, hey, you've got 2 more formulas here. And now you're saying something else. Do you want me to deactivate those? The answer is yes. Okay. All right. Now this is what I did. If you want to change it, you double click on it. You can go and make any changes. You say okay. All right. And okay, let me see now here. Let's try it, because we may have to do another step. Over 5 seconds. Let's try it over 5 seconds first of all. After 4, it should stop. If it's following that rule, it should stop. See? Okay, but it didn't go past the 5. That's why you didn't see the motion going back. So let's change this thing to 10 seconds. Okay. Now it's going to go for 4 seconds. It sits there for 2 seconds and it goes back. The only problem is it's wrong. So you got to find out why is it wrong, because let's check our formulas. This definitely is wrong because you jumped. You should start here and go back. Okay. So let's see now. Close this. Close that. We have to go and check our rule. Obviously, is this point. If the time is less than 6, sit there, and it did sit there. Else, this is equal to 8 inch per second. oh, 8 inches is sat at that location, and -2, this one. Oh, yes. And this in the video solution, I emphasize, here you have to put down -2 inch over 1 second, parenthesis, not time. Not time. It is time minus the force minus the 6 seconds. And the same thing down here. That's why it made the jump here. Because think about it like this. Think about, see, if the time is 6 seconds, this is going to be 0, and the position is going to be 8 inches. So it's going to be -6, okay? All right, so let's go down here. Okay, so again, parentheses. And then minus time -6. -6. 6 seconds. This is going to be wrong. 6 seconds. Okay. Let's check. Let's check code. This is too. I want to expand this thing to see what I did. Another braces. Braces. Where are my braces? Oh, wait a minute. Yeah. Okay, there's the braces. I have to close the parentheses here. The parentheses was not closed. See? Yes. Simulation with laws. So it's going to go there, sit there for 2 seconds, and go back without the jump. That jump happened because I did not subtract the 6. Yes. Close. Now, the way the GAs are going to mark your homework and on the final exam is that we're going to say, you know what? What we want you to do is to give us the position of the block and the rotation of this as a function of time. Give me these 2 plots. Give us these 2 plots. Give us these 2 plots. Okay? That's what we're going to ask you. So here's what we're going to do is we're going to say, okay, make a sensor. Point is, let's look at actually, let's look at this point, and the reference product is the track, and we're going to say, okay, simulation with laws. Rewind it first of all. Activate sensor. Now, if you ask for the first 2, in other words, 2 commands, remember there are 2 commands here. In this mechanism, there are 2 commands here, okay? One is the length command, the other one is the angle command, okay? The 2 commands in this mechanism. So you just give us these 2, length and angle, okay? And we're going to say, okay, simulate it. Same thing that you saw a minute ago. It's going to come back. Very good. And say graph. So we're going to get 2 curves. The green one is the angle. The green one is the angle. You see, it goes at 720 degrees per 4 seconds, which is 180 degrees in 1 second. It sits there at that angle, 720, and then it goes back in the opposite direction at the slower rate, half the rate. The yellow one is for the length command position of the length, okay, for the block position. You can see that with first 4 seconds, it's going to go at 2 inches per second. How do we know that? Because it's 8 inches over a 4 second interval. 8 inches over a 4 second interval. So that's 2 inches per second. It sits there idle. Velocity is, position is 8, doesn't change, which means velocity is 0, and then it drops. So what you need to do, I'm going to be very fussy about this thing. You're going to say screen capture, screen capture. Word document, paste. Okay, and this one is the yellow one, so that is the length position plot. So file, save as, browse, desktop, that folder, position plot. Position plot. Okay. It closes. Now select the green one. The scale changes to angles. Print screen. Word document. Paste. Okay, notice that I can look at the green stuff here, see the scale, file, save as, browse, that folder was right here. It's not the position that I want, it's the angle plot or something like that. This, yeah, angle plot, basically. Angle plot. Okay, you're done here. Close, rewind, save. Do not leave things at where they are. So here's what's going to happen. You, in today, what you did is you created your, if this was your homework, or this was a problem on the test, okay? So where am I here? Where's my folder? I think it was this. Okay, so if this is the test or the homework, you've got to give us the three-part plots, your product right here, lab 51, and these two plots. For next week's homework, if you do not give us these two plots, the way I described it, I have instructed the GAs to take half of your marks away. So the 10 marks for this problem is going to turn into a 5. And there is no discussion whatsoever, because I'll go and say, go watch the video. Go watch the recording of the lecture. Okay? Good. Now, why am I not spending any more time on this? Because, you know, this is not a programming course. The programming aspect, the basic programming aspect, you already have the knowledge. You're using it to write that code in a meaningful way. Okay? Even if I do 50 of these problems, just hypothetical, I'm not going to do that, but even if I did 50 of these problems, on the 51st, if you don't do it yourself, you're going to get stuck. Okay, any questions? No questions. Excellent. I like it. When there are no questions, it means either people are sleeping or they're really good. Okay, good. Now, the rest of the course, the remaining 5 lectures, including the portion 10 to 15 minutes that's left today, is going to be dealing with the concept of parameterization of a solid model or a model, CATIA model, and the concept of design table. So let me first tell you what I have in mind. Let me close this. I'm going to start a part file. We start with a part. Later on, we're going to go to assemblies in a few days. I'm going to make a box. Okay. So there we are. Okay. Something like that. Let me put some dimensions here. I'll call this thing, yeah, dimension these. Exit and path. And OK. OK, so we created the box. And if I click on f of x, see, this is called knowledge. knowledge, and remember we went to the knowledge, what was that? Knowledge where? Knowledge at where? Remember that? Knowledge is power. People can make a box and they can go and change the dimension. You know how to do that. You go to the sketch, you double click on it, you go and change the dimension, I don't know, to 2, and then come back. You don't have to have an engineering degree to do these. Okay, good. Now, if you click on f of x, it gives you all the junk that is done in this problem. You can scroll down. I haven't done much. That's why this list is not very extensive, but there we are. Now, if I click on this part, what shows you is the stuff, the dimensions, for example, that you put on that part. Remember, there was this, and there was that, and then there was the height. Remember that? Now, if you put the cursor on one of these dimensions right there, one of these dimensions, and select it, suddenly jumps in this long list. It suddenly jumps to that dimension, which has a very fancy name right here, and the value is 3.199. If you put the cursor on this guy and select it, left click, it jumps to that dimension in the list. It jumps to that dimension. This is the name of it, and this is the value of it. If you put the cursor on this, remember when you pad, it says first limit, second limit, etc. It's right here. Now, there's a couple of things you can do. You can see that. For example, if you want to change the height of the pad, you can do it right here. So you take that dimension, instead of being, I don't know, 0.78, which is the default, I'll make it 2. Apply. There we are. If you want to change this dimension, instead of going to the sketch, you select it. Okay, do you want this thing to be smaller? How about 1? Apply. There we are. Same thing with this. Now, the other thing is that these dimensions, if they're important to you, maybe you don't want to use it like this. That's the name of it. Literally, that's the name of it. But if you want to change this name so that you like it better, you can say, my pad height. Apply. You see, it changed into my pad height. If you looked at this and you don't like this name, you can change the name to my sketch width. Apply. Notice that it's no longer that ugly name. It's right there. If you want to change this, my sketch length. Okay, something like that. Apply. And if you say, wait a minute, I'm losing track of these things. What did I rename? You can go here to the filter and say rename parameters. Right there. If these are the important things to you, you may want to organize it like that. For example, you can go to the height. You can change that to 0.1. Apply. Length, change it to 5. Apply. There we go. Now, I want to tell you something about what I've done and something that we're going to call creating a parameters. These are, although it says parameters, but these are not parameters that I have created. This is just the concept of renaming something. Renaming something. That is not the same as creating a parameter. Okay, so let me move on. Say okay. Well, actually, I don't want to say okay. I am going to create 3 parameters, and these parameters, I'm going to call it, how about W, H, and I don't know, W, H, and L. How about that? W, H, and L. Now, how do I do this? These are just renaming. Look, all will give you all the junk, and the stuff that you have renamed is also in this list. But let me filter it. Okay. Notice here it says parameter, the type of it. Don't worry about this. We're not going to use it. Ours are all going to be single values. Okay. I want to create 3 parameters of the type length. So I go here. You select the length. Okay. Click on the new parameter. There is the name of the new parameter. I don't like that. I'm going to call it big H. And the value of it is 0. Another one. I don't like that. I'm going to call it W. And the value of it is 0. Another one. L. I don't like that. Sorry, what I meant. Oh, I didn't like what real 3, whatever it, or length 3. I called it L. Apply. So these are parameters that I've created, and they're of this values. Okay. Now notice that these are all 0, and this is going to cause you a great deal of grief the first time you do something like that. I did not change it. I could have set the value. I can change it now. I can change it now. But I'm not going to do that because I want to show you why it causes you grief. Okay, good. Now, I want to go back. These are the parameters that I've created with these bad values of 0. Bad idea. I'm going to say, okay, all right. I want to say this guy, this dimension is equal to L. You select it. Remember, I renamed it. It was like that. You remember that? I didn't have to rename it. I could have left it the way it was. It just was an ugly name. That's all. Add a formula equal to L. Right now, what are the parameters that I've created here? Let's see. Renamed one right there. See that? Did I call this? Did I not create a parameter called L? There. It's going to cause you a grief because the sketch is going to have dimension equal to 0. That's why I said you're not going to like this, but that's okay, no problem. Take that one, add a formula equal to W. Okay. Take the height, this path length, add a formula, rename parameter H. Okay. Apply. It said, well, wait a minute. You've got 3 dimensions and they're all 0. I don't like that. We say, fine, no problem. We're going to fix it. Go back to f of x, rename parameters. This one, I don't want the value 0. Remember I said it's going to cause you grief? Let's make it 1 or 2. This one, make it, I don't know, 3. This one, make it 1. Apply. No problem now. Okay, you might say, wait a minute, well, I could have done it here. Remember, I did it for you. I went this, took this, and I said, change this thing to some value, etc. But this is creating a parameter. Like, and let me show you what happens here. Say, okay. If you ask the CATIA to show you the parameters in the tree, it's going to be a very convenient way of changing it now. So here's the way you have to do it. If you're watching, you're going to go back to this particular moment. Tools, options, under infrastructure, part infrastructure, where is it? Part infrastructure, under the display. Now, if you just say the parameters, if you just say the parameters, check this, say okay. Notice that the tree got another branch called parameters, and the numbers are here. For example, I can go and change my L to 7 and say OK, and there we are. I can go to the height from here, double click on it, make it 0.1. OK, there we are. Etc. W equal to, I don't know, 2. So it got you. You don't have to go to this f of x and change it from there. At your will, if you create parameters and you want to change it, you do it. You display it on the tree and just double click on it. Now, if you also want to see the equations that you created or the formulas that you created, go back to the same place, tools, options, the same place that we are. Say, show me the relations also. Show me the relations also. Say OK. Say OK. And there's going to be another line here, and it gives you all those formulas that you create. Remember, you said my sketch length equal to L, my sketch width equal to W, etc. Now, just a word of caution. When you start doing this thing, a lot of times you're not careful. You write down L equal to that name, W equal to that. But remember, L, H, and W are parameters. If they're parameters, you cannot say H equal to, something. Parameters is a number. You cannot put it in an equation, basically, on the left side of an equation. I'm sure you're gonna be frustrated with this thing, because a lot of you will do L equal to that and W, and it's not gonna work. This is a prelude for the next 5 lectures. Are there any questions? Okay, so I'm going to start 2 minutes early, but there's something I've got to tell you. Ordinarily, after my presentation, I will create another session saying that the remaining 2 hours. So people come and ask questions, if they have any. And let me be very blunt with you, I can see the reason, of course. I can see the reason. Because we are recording these things and we are putting it on the, on Blackboard and YouTube and things like that. Because no attendance is taken, because the homework is not to be done during the lab, maybe during the last 10 weeks, I had in each one of these labs, let's say yours is about, I don't know, 100 people, and about 10 people show up, 5 people show up, and then they ask a question. Recently, of course, it has been even worse. I understand that. So the remaining 2 hours, I'm not going to do anything, but I've asked the GAs to set up virtual sessions. For example, the GA who marked your problem 2 is Matt. Matt, right after my lecture, he has already done that. Matt has set up a virtual session called, if you want to discuss problem 2 with me on the test, come here, okay? And I sent the same messages to Anthony and Greg, but I don't know whether they got it or not. But anyway, hopefully they got it, and they set up their own sessions. And Anthony marked problem number 1, and Greg marked problem number 3. So if you have questions about why you lost mark, etc., you go to that GA and discuss it with him in that virtual session. I'm going to disappear unless you have any questions. I'm not going to be here. The labs are run by the GAs, and in this fashion.